So welcome to storage classes. Storage classes. We have come across this phrase at different points in the discussion, but we have not discussed it because it requires coverage of different concepts. In fact, all the concepts are required. So I am covering it as the last one, storage classes. So program may be divided into functions. A program may be divided into files. So a program can be small, medium or large. So if the program is small program, then you will be writing the program as a single function, maybe in the single file. In a single file as a single function, that is the main function. So you will be writing only the main function. So that you can do. Now if the program is medium, then probably you will try to divide the program into what are called as functions, but still you restrict yourself to same file only. Different functions, but same file. But if the program is large, so dividing it just into functions is not enough. Probably you will be actually grouping the functions, that means similar functions, and then distributing those functions over several files. For example, you take college information system, maybe attendance related issues, marks related issues, and then scholarship related issues. All those can be treated as different things and they can be spread over different files. So that means a program can be spread over a single function, multiple functions, or it can be spread over multiple files also. And then what is the purpose of programming or programs? Programs are for data manipulation. As the amount of data increases, handling the data becomes complex task. You should be very careful. So because programming is all about data manipulation, so you should keep track of the data. You should have control over the data. So to have better control over the program, the concept of scope is introduced. To have better control over the program, the concept of scope is introduced. Concept of scope is introduced. It allows you to have better control over the program. Now to have better control over the storage, the concept of lifetime is introduced. Okay. So concept of scope, concept of lifetime. Scope is that part of the program test where all the references to the variable are same. That means if you have a variable, say variable is A. So wherever you refer to A, you will be referring to the same location. In that case, the scope is defined such that wherever you are able to refer it correctly, that is the scope. Now the scope can be block scope, function scope, and global scope. That means suppose you write like this. We use bracketing symbols to represent the block. So whatever you enclose in the block, in the flower brackets, that is called as block. So scope of a variable is block scope means if you declare a variable, some variable here, then whenever you refer to A within this one, so you will be referring to the same location. Maybe if you go to another one, say another one, say another function is there, say function 1. Okay, so if we have like this, then you cannot refer A here. You cannot refer A here. So the scope of A which you have declared here is only this one. This is block scope. So block is indicated by the opening and closing flower brackets. Opening and closing flower brackets. But be careful, there can be nesting of the blocks also. So next one is function scope. Function scope means, suppose if you declare it here, so here also in the case of block scope actually, so if we have another block like this, then you cannot access it here. A cannot be accessed here. That may be the same program, that may be the same function also. Say this is the main function. So main function, and say starts here, and let us say it ends here. Okay, now block scope means you are able to access A only within these flower brackets. You cannot access it here, or you cannot access it here also. So function scope means if a variable is declared here, then this is the main function. From this point to this point, this is the main function. So anywhere here you will be able to access the variable A. That means whenever you refer to A, you will be referring to the same location. So that is function scope. Global scope means anywhere you declare a variable, it will be accessed throughout the program. We will discuss examples for it. Through programming. After completion of this theory session, we'll discuss it. Then things will be clear for you. So block is indicated by opening and closing flower brackets. If you declare a variable within that block, that variable can be accessed only within that block. Function scope means if a variable is declared within a function, then it can be accessed only within this function. So you cannot access it in another function, say function 2. So function 2, so you cannot access this B. You cannot access this B here. B can be accessed only within this function. So this is function scope. Now the global scope is, say you declare somewhere here. So this integer C will be accessed within the main also, within the function 1, within the function 2, anywhere within the program. So lifetime is the time during which storage used to hold a value is bound to its name. So the name is bound to its storage. Remember, as and when you start executing the program, you will be invoking different functions. So when a function enters, maybe you allocate the memory, but when the function leaves, system automatically deallocates the memory. So the lifetime is the time during which the storage used to hold a value is bound to its name. So then why this scope and lifetime? In the case of C language, scope and lifetime are defined by what is called as storage class. So storage class defines the scope and lifetime of variable in a C program. Storage class defines the scope and lifetime of a variable in a C program. There are different types of storage classes that are supported by the C language: auto, register, extern, and then static. So these are the four storage classes that are supported by the C language. So how do you declare it? You declare it using storage class. Storage classes of auto, register, etc. are defined using what is called a storage class. So the example is here, or the general syntax here: storage class, data type, variable name equal to some value. So we have already discussed this: data type, variable name, and then if you want you can initialize, otherwise you can skip it. Square brackets indicates it is optional. Actually the square bracket should be here, because if you don't want to initialize, this should not, this is not required. So it should be here, not here. Okay. So storage class, you can see the data type is preceded by the storage class. You can replace the storage class with any of this: auto, register, static, extern. So 4 storage classes are supported by the C language. So auto is the default storage class. Auto is a default storage class. So if you have a variable with auto storage class, then it is restricted to a function in which it is declared. Definitely you cannot access it outside the function. Lifetime is during the execution of that function only. As soon as you exit from that function, it's no longer bound to its location. So can be called as local variables. It's better to initialize, because in some compilers, if don't initialize auto variables, they take garbage. But in some compilers they may not take, they may be initialized automatically, but it's better you initialize. So for example, sum, you want to add the sum of say 2, 3 and numbers, then before you write the statement like sum equal to sum plus sub a, so it's better you initialize it: sum equal to sum plus sum equal to 0. Initialize like that. Better to initialize. This is the general syntax for declaring auto, storage class name, and then data type, and then the variable name, okay, and then the variable name. So it is a default storage class. That means whether you use auto or not, it will be treated as auto only. Okay. So the auto variable, if it is declared within a block, it is restricted to that block. If it is declared in a function at the beginning of the function, then the scope of it is entire function. Next is register storage class. Register storage class, the way of declaring it is like this. So instead of storage class, we have to write register. So it informs that data be stored in registers if possible. So every microprocessor will have some registers. So we discussed about the memory hierarchy. So registers are the fastest storage we have. They will be present inside the microprocessor chip or inside the CPU. So every microprocessor will have few registers, 10, 20, 30 like that. And they will have limited capacity also. So 64 bits, each will be having 64 bits. Maybe all put together you may get to 1 KB only. Okay. So we have limited amount of memory, but registers are present inside the CPU. So if we store the data within the CPU, then you can very quickly access it. That means if you store it within the registers, you can quickly access it. So fast of access is very good. So treated as local variables only. Scope and lifetime is same as that of auto variables. But point to be remembered is, even though you declare it as a register variable, there is no guarantee that they will be stored in the registers. So it is up to the system to determine. Programmer cannot force it. Programmer can only make a request by using the storage class register. Static variables. Variables which retain the values between function invocations. They are called as static variables. They are initialized to 0 automatically, and the syntax is similar to the auto and register. Only thing is you replace the storage class with static. They retain the values between function invocations. That means, so if you call a function one time, then it will start with the variable. If you use a variable, static variable, so it may have initialized it to some value, it will start with that one. So you modify that one. So second time if you invoke the function again, then what happens? Retain the values between function invocation. That means it will start with the modified value. Again you may modify it. Again if you invoke the function next time, again it will start with the modified value. So they retain the values between the function invocations. Generally what happens with auto register storage classes is, okay, you have used auto and register storage class variable. So if you call a function, it will start with some value and you will be modifying it. But if you come again second time, so again it will be initialized to the original value. So whereas here, if you modify the value, the modified value will be taken when you invoke the function next time, second time, third time, like that. So the last storage class is extern storage class. So this is something like declaring a global variable in another file. If you want to access data across files, then you have to use extern storage class across the files. That means you have file 1, say file 2. So something which you have declared in file 1, you want to access in file 2, then you have to go with the extern storage class. If A is declared as global variable in say file 1, and if you want to use it in file 2, then declare it as extern in file 2. Note that you have to declare it as extern in file 2. Wherever you want to access it, declare it as extern. Okay, but somewhere within some other file, it should be declared outside that function, indicating that it is a global variable. So extern variables are automatically initialized. So we'll consider the programming examples for all this. And also there is what is called as local scope or global scope. Local variable, global variable. In simple terms, local variable means if you declare it within a block or function, then it will be valid only within that block or function. In that case, it is a local variable. Global variable means you will be declaring it somewhere, but it will be valid across the globes, across the functions, throughout the program, maybe across the files also. So that is global variable. So we'll discuss programming examples. So bye bye, see you again.